All right. Thank you. Hi, everyone. It's really great to be here. I wanted to start by just thanking the organizers and the staff from the conference. Putting together an event like this is a tremendous level of effort, and it's been just an incredible couple of days so far. So thanks. So I titled this talk From Humble Beginnings, both as a nod to Thumbtack's engineering culture, and as I was putting together this talk, just going through and reflecting on how far we've come from the past few years and how much we've accomplished. It's been really cool to kind of take that look back, and we've really come a long way. So a little bit about me. So I lead infrastructure and data science at Thumbtack, and been there about 4 years. Joined towards the end of 2014. Before that, I was at Apple for a little over like 2.5 years, and actually started my career doing research in machine learning and in semiconductor manufacturing. So Thumbtack, this is Thumbtack. We are an online marketplace for local services, and we have about 900 categories from like house cleaning, DJs, bartenders, piano tutors, things like that. I'm actually curious to know how many of you have actually heard of Thumbtack. We're US only at this point, so I figured not many of you had heard of us. But yeah, so it's an app that looks kind of like that. And fortunately, we don't look like that anymore, but we actually started 10 years ago with a little website. Been around for a while. Through a bunch of fundraising and growth, we've raised about $270 million so far. The team is about 600 people now across 2 offices. And yeah, so I joined towards the end of 2014 here. So when I was thinking about putting together this talk, really the thing I kept coming back to was wanting to share some of our experiences building data infrastructure, building out the data engineering team, and just all the things that we've been so fortunate to learn from our own mistakes and from input from good friends and colleagues at companies around San Francisco, and some of which are here today from Slack and Stitch Fix and many others. And as I was kind of thinking about how to structure some of this, I was kind of reflecting on there's really 2 groups of people that I often see here where, at small companies that we talk to, often with like just a handful of engineers, we'll maybe not even have a data team, maybe have one engineer off kind of hacking things together with Python scripts and cron jobs. And if you're lucky, it might even like talk to PagerDuty so that you know it broke 3 days ago. And on the big company side, we often talk to people where there's just data like just everywhere in many different systems. Some of it's in Oracle and Vertica, and there's all these different places that data is being stored and used. And so then usually what happens is someone gets the idea of doing like a big migration and centralizing and building out the data warehouse, and starts this effort often in collaboration with a data platform vendor and professional services. And a few $1 million later, either this is in the worst case like a total failure and gets rolled back, or in the best case, it reminds me of like that XKCD comic. So, well, we started with like 14 standards and now we have 15. This is happening a lot with like, oh, we had all these like 14 data platforms and we've just added the 15th one. But the main thing that I hope to share today in this talk is from some of our experiences to give some guideposts for how to think about making decisions around bringing up data systems and teams, how to partner with a business and work with your counterparts and analytics and other teams to make this successful. And then a little bit of how to think about building for scale and when and how that starts to make sense. And I wanted to do that by kind of partitioning our time at Thumbtack into 3 eras. So at Thumbtack, I'll start with the dark ages, which was like basically what was there when I showed up. The Renaissance, which was our kind of MVP first cut at building out data infrastructure, and then a little bit of where we are today and how we've started building for scale and kind of what's coming down the pipe next. So I'll start with this kind of first era, which is really the state of the world when I showed up at Thumbtack in late 2014. And so I was actually hired at Thumbtack as a data scientist. And I was the first data scientist. We had 15 engineers at the time. And so the company hired me, and I figured I'd jump in and kind of roll up my sleeves and get back to doing some more hands-on machine learning work. And pretty much realized right away that we had none of the infrastructure in place to support doing machine learning in production. And so started in on that. And this is what the kind of system looked like when I arrived. So I've split up the world on the right here. Top was our product, then our quote-unquote data infrastructure, and then some of the BI tools that we had on top of it. So the product, we essentially had the PHP monolith with Postgres, something like 500,000 lines of PHP when I got there, and but our data infrastructure essentially was non-existent. Someone had stood up a Mongo cluster. They were piping event data into this Mongo cluster, and wrote a bunch of Python scripts with cron to aggregate the data and summarize it. And then really there were just a handful of ways for the team to look at this data. But really problematic was teams really wanted to be able to look at event data and relational data and be able to join these and look at kind of funnels in the product combined with state from the relational databases. And so they couldn't do that, and it was, on top of that, this whole thing was really fragile and slow and was causing all kinds of problems. And what I thought was interesting about Thumbtack in this phase is, they hired me with kind of the right problem in mind, right? Like, so the team wanted to work with data, get access to data, and use data to make the business successful. But the kind of solution that was envisioned of bringing in data science wasn't necessarily the right one, right? So kind of starting with a data science role before really getting the foundations in place with data engineering. And so I'd done infrastructure at the past at Apple and pretty much jumped right into this during my early time there in terms of building out our data infrastructure. And these are kind of the things we wanted to go after solving first. So first and foremost was just getting all of Thumbtack's data together in one place so that people who needed to work with data could get at it and work with it easily. I thought it would be nice to kind of continue to separate our data infrastructure and production infrastructure and not have individuals querying a production Postgres replica. And then really start kind of building the foundations of scalability for future growth. So this is essentially our first cut, our MVP at data infrastructure back from 2015 when we first started here. And by this time, we had started introducing a number of microservices and writing a bit less PHP. Using Postgres and Dynamo, so all of the products on AWS. And from these, then, we built a number of ETL pipelines. We stood up on a Cloudera cluster, wrote a bunch of pipelines in Spark, Airflow to orchestrate the whole thing, and then we were using Impala for distributed SQL to support analytics tools using Mode Analytics, a little bit of Hue, and a variety of other internal dashboards. And so this got us towards some of those early goals, like we had no one touching production anymore, and we no longer had to teach marketing folks how to set up SSH tunnels to query Postgres, which I felt a lot better about. And got us this kind of foundations of scalability. But most importantly, we got all of our Postgres data, relational data, and events data in one place so that teams could work with that. But there were a number of other things we did along the way that helped us kind of get to success. And a lot of them ended up being things that were kind of hacky, but really connected business value early on. Because remember, this is just me and one or two other engineers. And so we wanted to be really careful about continuing to deliver value to the business while we were getting all these foundational things in place. So one of the things we did that was over a weekend, we built kind of a web UI for our analysts, where they could take CSV files, we would look at it and infer the schema, and create a table in Impala Hive for teams to work with. And this ended up being really important for a lot of teams because they could go and kind of unblock themselves and figure out their own business workflow. They'd grab some data they had in Excel or Google Sheets and stash it into Impala. And it got us a quick path to self-serve, where data engineers didn't need to be in the critical path. And that ended up being really helpful early on to get kind of buy-in for this system that we were building. The other thing that we did that I thought was really, really helpful was essentially building this last-mile ETL for the analysts, where we gave them the ability to define tables with essentially materialized views in SQL queries for all of the key entities in the product. And then they'd go and define these, so we had a customers table with all of the metrics and KPIs about customers that we cared about that they can go and work with. So we had all of our kind of ETL pipelines that we're bringing up behind the scenes. But then this became the primary interface for both the analysts and for the rest of the business, for even less technical people to get at and work with data in the platform. And we found this to be really helpful. You can imagine, even for someone non-technical who maybe barely knows SQL, select star from customers ended up being pretty easy for them to kind of engage with and get started with. And gave those teams kind of an on-ramp to using SQL in their day-to-day. And we stuck this all in a database we called A, so it showed up nice near the top of the list of databases in Impala. Made things easy. So this was our kind of MVP, and from this, we saw the team, we got to a point where everybody could start building reports and dashboards and get things in place for their workflows. We enabled the analytics team to start doing a lot more exploratory analysis and looking at data as part of their day-to-day. And also got a lot of our early A/B testing in place. So we've built our own in-house A/B testing framework, and being able to use this event data to drive A/B tests was really an important kind of thing for the team early on. And for us, some of the learnings from this experience, it was really important to just find this kind of right starting place where we weren't trying to build a perfect system at first, because we're just starting from zero. And so being willing to be hacky about some of those design choices early on gave us this ability to kind of deliver lots of business value, help people with their kind of core workflows, and then kind of move towards replacing those over time with more mature production quality pipelines. And I think, along the way, kind of getting a little bit of this roles thing, which I'll talk about more later, but got us to kind of, but this process kind of got us to realize, hey, we actually need a lot more investment in data engineering than data science right now. So moving to kind of a little bit of where we are today, as we've started to build for scale, there were a few things that came up. So after we had our MVP in place, there were a lot of things that ended up being really successful. So our monthly active SQL users, at some point I think we hit basically 2/3 of the company, even people in customer support or operations, non-technical roles, had learned a bit of SQL, were using it in their day-to-day work, and became users of this system that we had put in place. And we got to a point where, for all of our kind of product decisions and company strategy, this data that we were collecting from both just core metrics and from running A/B tests on this platform really became important inputs to a lot of decision making and how we operate on a day-to-day. And so we ended up kind of being victims of our own success. Like we quickly hit a bunch of scaling challenges. The biggest was a really resource contention. So at the time, we're kind of scheduling all these like Spark jobs and Impala workloads on the same big monolithic Cloudera cluster. And what ended up happening was, well, all the analysts would schedule their dashboards to refresh at like 7 o'clock in the morning, so they would all be fresh when they come into work at 9. And so we'd have our like overnight Spark jobs running, and then we'd get this huge wall of Impala queries coming in, and it would pretty much bring the whole thing to its knees. And so we had a lot of work we had to do to kind of deal with all this resource contention between Spark and Impala and different workloads. And relatedly, like it wasn't elastic, right? So we had some fixed set of Hadoop nodes in this cluster. Ideally, we'd be able to scale up and scale down a little bit. But even with Cloudera Manager and Puppet and other automation, it would still take a few hours to bring a new node online, and especially when you consider like the data rebalancing you need to make Impala work well. So we kind of had this, somewhat over-provisioned cluster to be able to handle these spiky workloads, and that translated in turn to just a lot of operational overhead. So, if you've ever maintained a big Hadoop cluster, even on AWS, at a certain scale, like there's all kinds of things operationally that tend to go wrong. I think at some point we hit in those clusters like more than 500 magnetic disks, and so there's always a drive failing or a node going out. And at least at the time, Impala had a nice quirk of it would kill all in-flight queries whenever anything went wrong with a node in the cluster. And so then we'd end up having an engineer having to go and rerun all the jobs and backfill data, and ended up being a real burden. So we started thinking about a V2 of our data infrastructure at this point in time, and kind of outlined a set of objectives. I actually pulled this from our RFC that we wrote back 2 years ago or so, and it was nice to kind of see, well, we ended up really delivering on a lot of these. But we started with this kind of point of elasticity. Well, we recognized from our workloads they were really dynamic, and we needed to be able to accommodate just a lot of variability in workloads through time. A second one, we were storing all of our data on HDFS, and thinking about losing a name node kept me awake at night in terms of worrying about data durability. But even just the kind of availability of HDFS and dealing with all that, we wanted to kind of relocate our data elsewhere to S3 or similar. A third was decoupling. So we also recognized, from running this for a year or so, that our Spark workloads and our Impala workloads looked quite different, and we really wanted to be able to decouple our distributed SQL and Spark so that we could optimize systems for both independently, rather than trying to kind of co-locate all this on one big cluster. And then I mentioned this operational overhead. I think this is particularly important, especially through the lens of, I've been in San Francisco for a few years, and trying to hire engineers is incredibly hard. It's a competitive market. So we have a small engineering team, and they tend to be quite expensive because it's San Francisco. And so we want to be really thoughtful about how we spend our engineering resources, both from a pure cost perspective, but also from an opportunity cost of, I have a finite set of engineers, and if they're working on keeping Hadoop happy, they're not working on moving the product forward. And that's a pretty tough trade-off for a small startup like us. So we ended up really kind of boiling down our choices to looking at GCP versus AWS. At the time, Athena hadn't been introduced yet, and we kind of wrote off Presto right away because Presto, in terms of some of the operational challenges, is not terribly different from Impala. And so there were, we started our decision process kind of with looking at BigQuery versus Redshift and boiled it down to a few kind of key comparison points, dimensions that we cared about. There are many other kind of interesting things to think about in terms of like access controls and security and various other things, but these ended up being some of the most important ones to us. And so along with BigQuery being fully managed, some things that stood out as interesting is BigQuery supports nested data types, complex data types, which we had been using heavily in Impala, and because we have kind of thrift events coming off of the product, and we essentially mapped those directly into tables in the data warehouse. We wanted to be able to do the same with our distributed SQL engine, so that we didn't have to kind of flatten records or otherwise restructure the schema, and ensure that kind of analysts and product engineers are looking at the same data across both systems. And BigQuery also kind of supported streaming inserts, and we thought that'd be nice to give our analysts the ability to look at data in near real time off of the product. We also looked at the Spark, where we were running Spark workloads. And at least in 2016, Dataproc was minutely billing, and you could actually bring up a cluster in like 1 to 2 minutes. And that was attractive to us through this lens of worrying about elasticity, where we knew that we wanted to be able to kind of dynamically scale for different workloads. And so from that perspective, Dataproc looked pretty compelling to us. So this is roughly, this is kind of a simplified diagram, but essentially what things look like today at Thumbtack. We have quite a lot of Go services at this point. I think somewhere around like 30 to 40 microservices in production. We still haven't gotten rid of the PHP monolith. We're in the process. But now we have many ETL pipelines running. Airflow is scheduling hundreds of jobs a day. And we run all of these as Spark Dataproc clusters, writing data out to cloud storage and then into BigQuery. And we've continued to use Mode as our primary analytics tool. And so this delivered on a lot of these things. So BigQuery, we've kind of totally decoupled our Spark workloads from our ETL pipelines. I think the thing that's been most exciting to me to see kind of with the small team that we have, our ops overhead went from like alerts firing all the time and engineers having to go deal with like systems being broken to like we've at times gone like more than a week with not a single alert going off. And that's been just a huge burden off of the team in terms of just no distractions coming out of this side of the world. I think one of the biggest wins for us here along these lines, and part of the reason that it's been so quiet in terms of an on-call, is that we heavily use job-scoped clusters, and I'll talk a little bit more about that. But what it means is that essentially all of our instances are ephemeral. We don't have standing machines at all, and so there's not a lot of stuff that can go wrong, kind of from a quiescent state. So job-scoped clusters, essentially the way we've done this, so we have an Airflow operator that wraps this. The way it works, we go to Dataproc and we say, hey, we need a cluster with 20 nodes, and we bring it up, and then we schedule the Spark job in question on that cluster, and after the job successfully completes, we tear down the cluster and we move on. So we actually, so this whole process, we never schedule multiple Spark jobs all on the same cluster. It's a one-to-one mapping job to cluster. And from an ops perspective, that ends up being really, really nice. So, because we can wrap and abstract this away for the team, where for our engineers, for the rest of the team, all they need to worry about is, okay, what's the Spark class that I'm going to run? How many workers do I need in my Spark cluster? And we'll take care of all the rest in terms of monitoring and logging and alerting. But also we can kind of bake in retries. So we'll like retry the job on the same cluster. If the job fails, we can try again. If the whole thing's still not working, we can kind of tear down the cluster, bring up a new one, and try to schedule that again. And it's, in practice, translated to a lot of resiliency in our pipelines and it's much more rare that things break in a way where an engineer needs to get involved and do something about it. So the other thing I wanted to highlight was this was a big migration. At this point, we had hundreds of people using Impala, and we needed to get them over to using BigQuery. And we were looking for ways to kind of show the value of the system early on and get kind of momentum behind the new system, rather than kind of going away from the team for 6 months and coming back with something. So what we did was, I talked about those kind of like A tables earlier, but essentially the last mile of ETL that we've got in place, we just set up an Airflow job to copy those over to BigQuery, and essentially daily copied over all of those A tables. And since that was the primary interface for many people, that gave the team a chance to work directly with BigQuery pretty quickly. Alongside that, so BigQuery, you can actually create a BigQuery table on top of the state of a Google Sheets spreadsheet. And for analysts, for less technical people, this became a tool that they started using prolifically to replace the old like CSV thing, where they could kind of quickly bring in data from a spreadsheet and join it with some other stuff from the product. And through this process, like our analysts ended up becoming really internal evangelists for this new thing, because they're like just blown away by BigQuery. They really love the tool, and so then they kind of helped us with bringing the rest of the company along in terms of migrating over to the new system. And then kind of working in parallel to that team, we could continue our work at the foundational levels to migrate the rest of the data warehouse, one ETL pipeline at a time, into the new infrastructure. And so, if you're at one of those bigger companies, I was kind of thinking of that when I started this process of, hey, we've got a really big team and we need to think through how to migrate successfully. And this ended up being kind of a strategy that worked really, really well for us. But not everything was perfect, and there was definitely challenges that we still deal with. So I remember, this was like a year ago, I remember waking up to this alert at 5 a.m. from PagerDuty for one of those tables, A tables, that had broken. We dug in more, and something in the logs in BigQuery mentioned G drive, and so this was concerning to me, and started looking in a little bit more. And we were like, well, this makes no sense. But it ended up becoming a postmortem that we wrote. So someone had introduced a Google Sheets-based like BigQuery table upstream of one of the A tables, and then reordered the tab in the Google spreadsheets, and it ended up kind of propagating downstream and breaking the whole pipeline. And so we had things like this that we had to iron out along the way, where because of this kind of these things that we had put in place to drive towards productivity for the teams, we needed to do a lot of work around being careful and building the right guardrails in to make sure that things like this didn't happen. But ultimately, this ended up becoming really successful for us. What I thought was really interesting is, despite spinning up hundreds of clusters a day, so we're up to about 600 to 700 Spark clusters a day we create and destroy. The costs were not terribly different from the big monolithic cluster that we had before. And I think a big part of this is the elasticity, right? That we're not paying for resources that are just sitting around idle, and we're fully utilizing the compute resources that we're scheduling. And along with that, we've managed to kind of continue growing our BigQuery users internally. It's seen a lot of adoption, again, just across both technical and non-technical teams. And we've really built this culture of kind of like self-serve data across the company. And alongside that, I think it's really helped us grow the data org across the different data teams. So along with the kind of 600 people in the company, across data engineering, machine learning, data science, analytics, and our other data-related functions, we have a team of about 40 people now that we're able to support with this infrastructure, working on a variety of problems within the business. But I wanted to actually sidebar here and talk a little bit about the different roles on the data side of a company. There was this article recently by Elena from Airbnb that really resonated with me in terms of how we see the world at Thumbtack. But essentially, we think of 4 different roles on the data side. Data engineering, which is essentially what I was doing early on, where worrying about building infrastructure, standing up pipelines, and a lot of this foundational work. But paired with data science and analytics, where we really see 3 kind of important roles. Within what we call data science at Thumbtack, we think of kind of 2 tracks. The experimentation and inference side, which is more worried about traditionally people with a classical statistics background, probably less coders, and really worried with ensuring we have a level of rigor around how we set up and run A/B tests and experiments. We have a machine learning data science team, which is currently the majority of our data scientists, working on building machine learning models in the product, building data products, usually working kind of in Jupyter and Python. And then our biggest group really is this like product and business analytics team that works directly with product teams on delivering insights and understanding how the company is doing, understanding key metrics, and all that kind of thing. And so back in our MVP, when I was first working on the data engineering side of things at Thumbtack, we started with data science, but really we needed this data engineering role. And so I'd encourage you, as you're thinking about like these different roles in your organization, give some thought to like how and when they're introduced and when you are actually able to successfully support them. Because really we completely sidestepped our investment in data science until much later, really focusing on data engineering and analytics. And it's only now that we have this kind of solid infrastructure in place, that we've built the fundamentals, that we're able to kind of take that next step to start thinking about how to apply these other roles and set them up for success within the context of the rest of the organization. So to summarize, I think I really want to highlight this thought around just sequencing, being willing to be hacky and kind of take these steps to show business value from the things that you're building on the data infrastructure side of the world. But I think it's really important to also have a plan for how you're going to address that, because it is tech debt, right? Having some random pipeline with CSV files coming in is tech debt that we need to think about how to pay down over time. And so I think it really is important for having some idea of how you're going to mitigate that and how you're going to move that into this kind of core foundation that's really, really solid. And to my point, just give some thought to the roles that make sense in your organization and when. It's something I see again and again that companies go and hire out a bunch of data scientists, and those data scientists end up leaving in frustration because they have none of these kind of core foundational things in place that will make them be successful and unlock the skills that they're best at. So that's it. That's my talk in 3 parts. Would love to talk more in person afterwards, and happy to take some questions. Thanks.
Let's take some questions then. The first question comes from Milan. He wants to know, what would you call the minimal stack for the most essential business insights? How to start with BI and what brings the most ROI?
Yeah, so I wrote a blog post about this probably about a year ago, called like Getting Started with Data Infrastructure, because I think this is a really great question, and I think it's something that a lot of companies really struggle with, like where to even start. Honestly, I think the main point that I usually orient people around is get everything into SQL. Like, give people a way to work with SQL. It's the universal language that so many people can work with. And so even if that's querying a postcodes replica, like that's a starting point. But focus on that and giving teams a way to work with data in SQL. And then I think then you can worry about incrementally layering on the rest. But yeah.
All right. Giving teams the ability to put any of their data into the platform sounds crazy.
I agree.
You had any quality metrics, sanity checks, etc. in place?
Yeah, absolutely. So this is where I like to think of this as there's like the core where we provide a lot of guarantees, and then there's the fringe where it's like you're on your own. We have it all in one place so that people can work with it, but we kind of establish very clear understanding with the organization that, okay, we're going to provide SLAs around this core. There's data quality checks, there's tests, there's all of those kind of important things in place around the core, and you can trust that because we've vetted it. But the fringes, like because you uploaded your CSV file, like we're not gonna provide any kind of guarantees there. And so what we found is that most teams are willing to kind of they have their own best sense of what's an acceptable level of risk and how they can prioritize. And if that kind of doesn't make sense for them, they'll come work with us to get kind of workflows built into that core or pipelines built into that core for the platform.
Absolutely. As the only data scientist slash data analyst in my company, I am in the same boat that you were in starting out. How did you grow the team and sell the need for engineers and data scientists to management?
Yeah, I'd really point to this, like find ways to deliver business value, because that's how you build credibility. So for me, we looked for ways to kind of get like what is the minimum set of things that we can do. I think this point around getting things into SQL and helping show metrics to the business was important for me, but there may be similar opportunities in your organization for connecting the work that you're doing to a real business need. And as you solve for that, I think then you can build this credibility to build a team around this core thing that you're trying to get in place.
Okay, and how do you handle schema evolution and data rewind in that central customers table?
It's funny because I was just talking to Anand about this yesterday. So the way that we handle it today, and because this is on BigQuery, it's essentially just a materialized view. So we will just kind of replace. BigQuery can do an atomic replace of a schema. So we'll have the old version, we'll have the new version, we'll replace it. The big asterisk there is thinking through downstream dependencies, and so we kind of have different tiers where for things that are primarily used for analytics, we will be a little bit more flexible on schema evolution, and we'll let teams kind of just change things. But for things that are driving engineering systems, feeding back into search indexing or similar, we will be much more rigorous about schema evolution and that things need to be backwards compatible.
Right on. I think we have time for one more question from Sabiro. How much time goes into dashboards creation, maintenance, versus data engineering task?
Yeah, so we've split where we put all the responsibility for dashboard creation and management with our analytics team. And so they own the dashboards, they own all of those tools, and then we own the infrastructure side. So it's hard to kind of directly answer this, but there are, certainly on the analytics side, there are a bunch of analysts who are working on dashboards and all that.
All right. I think we're out of time. Thank you very much.
Cool, thanks.